right? So now we will derive the equation for back EMF, right? So in order to derive the back EMF, we need to consider some terms. That is, first one, Z is equals to total number of armature conductors, right? So why it is required? Because in the Fleming's left hand rule we came to know that if we are going to use only two conductors, after rotating 90 degree, the conductors will be in the dead centers. Andre motor will not rotate. Adar sambandhi em madbekri, we need to go for more number of conductors. Yes, 2. Right? So let us consider that as Z, total number of armature conductors. Next, as I have already told, due to current ISH flowing through the field resistor, there will be change in flux. Let me call that as phi. That is useful flux per pole, and usually flux is measured in terms of Webers. Next, right, so because of this mechanical power, the motor will be rotating. With what speed it is rotating? Let me call it as N. Speed of armature in revolution per minute. This is very important. This is in terms of revolution per minute. Right? Next, P, number of poles. Right? So whether I am using only 2 poles or I am using, right, so like this, 4 poles, right? So I can use even 6 poles, 8 poles, that will be denoted by the letter P. That is number of poles. Last is the number of parallel paths, E. Right? So now, due to current ISH flowing through the field resistor, there will be change in flux. That is flux cut by conductor in one revolution. Let me call it as d phi is equals to how many number of poles? P into flux. That is phi into P. Next, the time taken by conductor to make one revolution. Right? So N is what? Revolution per minute. Revolution per second ಆದರೆ ಏನಾಗುತ್ತೆ ರೀ? It will be N by 60. The time taken to complete one revolution, andre it is just like your frequency. What is the relation between frequency and time? It will be 1 by f. Therefore I will get it as 60 by n. ಹೇಳೋದು ಗೊತ್ತಾಗತ್ತಲ್ರಿ? n ಏನೈತಲ್ಲ, it is revolution per minute. Therefore if you want to calculate revolution per second, then divide it by 60. Time taken for one revolution will be 1 by this. Therefore it will be 60 by n. Therefore induced EMF, what is that? E is equals to d phi by dt. I know d phi, I know dt. Substitute d phi and dt. I will get 5 pn divided by 60 volts. d phi by dt. This is what? EMF induced per conductor, only for one conductor. Now EMF induced in total parallel path is equals to EMF induced per conductor into number of conductors per parallel path. EMF induced per parallel path is equals to ಒಂದು ಕಂಡಕ್ಟರ್ನಾಗ ಎಷ್ಟು EMF ಆಗಿರ್ತೈತಿ ಇಂಟು ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಕಂಡಕ್ಟರ್. ರೈಟ್? ಸೊ ಈಗ ಹೆಂಗಂದ್ರೆ ಒಂದು ಬಸ್ನಾಗ 50 ಮಂದಿ ಹೊಂಟಾರಂದ್ರೆ 50 ಬಸ್ನಾಗ ಎಷ್ಟು ಮಂದಿ ಹೊಂಟಾರಂದ್ರೆ 50 ಇಂಟು 50. ಹಂಗತೆ ಒಂದು ಕಂಡಕ್ಟರ್ನಾಗ ಜನ್ರೇಟ್ ಆಗಿದ್ದು ಇಂಟು ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಕಂಡಕ್ಟರ್ ಅಂದರೆ ಐ ವಿಲ್ ಗೆಟ್ ಟೋಟಲ್ ಇಂಡ್ಯೂಸ್ಡ್ EMF. ದಟ್ ಈಸ್ back EMF. EB is equals to EMF induced per conductor 5pn by 60 and number of conductors per parallel path Z by A. I will get ZNP divided by 60A. Right? So this derivation is very important because we will solve many problems on this equation, right? So EB is equals to 5ZNP divided by 60A, right? So now we will go for equation 1. V is equals to EB plus IA into RA. Multiply IA on both sides. What I will get? V into IA is equals to EB into IA plus IA square into RA, right? So what is V into I? It is power, right? So V into IA, electrical power input to the armature, IA square RA, copper loss, EB into IA, electrical equivalent of the mechanical power developed, right? So in the previous video I have told there will be some mechanical power developed to oppose the back EMF, right? So ಮೂರು equation ನೋಡ್ರಿ, these are equations of power only. P is equals to EI or I square R or E square by R. ಇಲ್ಲೇ ಮೂರು equation ಏನದಾವು, ಫಸ್ಟ್ ಎರಡು ಟರ್ಮ್ ಅದಾವು. V into IA is equals to EB into IA plus I square RA ಅಂದ್ರೆ V into IA electrical power input to the armature, I square R ಅಂದ್ರೆ copper loss, EB into IA ಅಂದ್ರೆ it is electrical equivalent to the mechanical power, which includes iron loss as well as mechanical losses. Now efficiency, right? So efficiency can be derived as this equation, from this equation. Mechanical power developed by the armature divided by electrical power input to the armature. Usually efficiency and it is output divided by input. Here output is what? Mechanical power developed. Input is what? Electrical power input given. That is EB IA divided by V into IA, or it is EB divided by V. In the previous video only I told that back EMF is very important. See, higher the back EMF, higher will be the efficiency, because back EMF is in numerator. ಅದಕ್ಕೆ ಯಾವಾಗಲೂ ಮೋಟರ್ ಡಿಸೈನ್ ಮಾಡೋ ಹೊತ್ನಾಗ ಮೇಕ್ ಶೂರ್ ದಟ್ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಸಫಿಷಿಯಂಟ್ ಬ್ಯಾಕ್ EMF to drive the armature. Next, that is higher the value of EB, higher will be the motor efficiency, right? So now in this equation what we will do is we'll take motor power, that is EB into IA, that is bring this to LHS. What I will get? VIA minus IA square RA, right? So differentiate with respect to IA, what I will get? V minus 2IA into RA. If you differentiate with IA, ಏನಾಗತ್ರಿ? Differentiation of IA with respect to IA is 1 and differentiation of IA square is 2IA, right? So for maximum power developed, what we need to have is, we need to have dPm divided by dIA is equals to 0. That is, equate this equation to 0. What I will get? V minus 2IA RA equals to 0, or IA RA is equals to V by 2. Therefore I will get EB is equals to V minus V by 2 or V by 2. That is, in order to have the maximum efficiency or in order to have the maximum power, the back EMF should be exactly half of the applied voltage, right? So but unfortunately because of some losses it is not equals to half of the back EMF or half of the applied voltage. That is, but in practice DC motors are designated to satisfy this given above equation, because if EB equals to V by 2, the current flowing through the armature will be far more than the rated current and lot of input power will be wasted in the form of heat. That we are going to call it as loss, right? So always, because of this, always the efficiency of DC motor will be less than 50%. ಈಗ ಏನಾಗುತ್ತೆ ರೀ, ಬ್ಯಾಕ್ ಇ ಎಮ್ ಎಫ್ ಈಸ್ ಈಕ್ವಸ್ ಟು ಏನಿರಬೇಕು, ವಿ ಬಿ ಬೈ 2 ಇರಬೇಕು. ಅಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪವರ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿಸ್ ಕಂಡೀಷನ್. ಬಟ್ ಹಿಂಗೆ ಆಗ್ಬೇಕಂದ್ರೆ ಏನಾಗಬೇಕು, the armature will be far more than the rated current. ಅಂದರೆ ಇನ್ಪುಟ್ ಕರೆಂಟ್ ಜಾಸ್ತಿ ಬ್ಯಾಕ್ ಇ ಎಮ್ ಎಫ್ನಾಗ ವೇಸ್ಟ್ ಆಗುತ್ತೆ. ದ್ಯಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಾಲ್ ಇಟ್ ಆಸ್ ಲಾಸ್. ಹಾಗತ್ತೆ ಲಾಸ್ ಆಗೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, ವಿ ಆರ್ ಅನೇಬಲ್ ಟು ಗೆಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಪವರ್, ಮ್ಯಾಕ್ಸಿಮಮ್ ಎಫಿಷಿಯನ್ಸಿ. ಅದಕ್ಕೆ ಎಫಿಷಿಯನ್ಸಿ ವಿಲ್ ಬಿ ಆಲ್ವೇಸ್ ಲೆಸ್ ದ್ಯಾನ್ 50%. Right? So remaining thing we will discuss in the next class.